Okay, so we have question number 5 from February, March 2019, paper 4, variant 2. This is a question about graphs of functions, and here we have a cubic graph, y equals 3/10 of x cubed minus 2x. The highest power is x cubed, is a power of 3, therefore it means it's a cubic graph, which if it has a positive in front of the x cube, will have some sort of shape that looks like this, some shape like that. That's how a cubic graph looks when it has a positive x cube. If it's a negative x cube, it will have this type of shape. So it should have this type of shape, okay, when we draw it, something like that, okay. Now, to fill out the table, there's different ways you could do it. You could just take your calculator, you could set this up by putting 3/10, 3/10, and then your x cubed, so you just put whatever x is here, minus 3, close bracket, and then cubed, and then minus 2x, then minus 2, and then I'll put whatever x is for the first value, minus 3, close the bracket, and press equals, okay, which gives you minus 2.1. Okay, and then what you could do to make sure that you're on the right tracks, for example, you could put minus 1.5 in there just to see if you get the right answer according to a value that's already been given in the table, because they already told you what minus 1.5 should be. So you can go back and change the minus 3 to minus 1.5 and verify that you get the right answer. Well, that comes out as 1.9875, which if you round it to one decimal place, as this has been rounded, you can see that will become 2.0, 1.9875, 1.9875. You round it to one decimal place, okay, that has to change, so it's going to become 2.0. So you can see that we're on the right tracks, okay. But I think a far more efficient way of dealing with this, especially when there's quite a few numbers to fill out, is to use what's called the table function. So you can go to menu, and when we look for the one that looks like a table, which is this one here, which is number 8. Okay, if you're not sure, you can just go through all the options until you see the one that says table. Okay, and you can see that's the one, press equals, or you could have pressed 8 straight away, and you actually just put the whole equation in the way it looks here. So you're going to put 3/10, and then you're going to have x cubed. So you use the x in this area, in this button here, this x, and you press x, and then you press cubed, minus 2 times, and again x, and then you press equals, and then it'll ask you in case you want to have another table of values next to it for another function. You don't, so just press equals again, and then it says start and end. So start is minus 3, that's where you want to start the table from, and end is 3, you want to end at 3. So press start, minus 3, and you press equals, and you put end, 3, and then it says step. Okay, now that means how it changes, like it goes up by 1s or 2s, or goes up by halves or whatever. Here we're going up by 1s, but at this particular point you're going to go up by, in these 2 points you're going to go up by 0.5. So what you could do, well, because they're already, the 0.5 ones are already filled in, you could just say step 1, no problem, okay? You could just do that, and that's fine, because these ones are already filled in. So if they weren't filled in, you could have put step 0.5, and then just put in the values that you need from your table. But we can put step 1, just press equals, and it makes the table for us. I don't know if you can see it that well. If I can maybe make this a bit bigger, see if I can do that. Move this up here a bit, make that a bit bigger. Okay, so you can see that when x is minus 3, gives us f of x is minus 2.1. It's automatically rounded it to one decimal place, actually. Okay, and when x is minus 2, okay, y is 1.6. We can write here 1.6. Oops, 1.6. And then we've got to go all the way to x equals 1. When x equals 1, well, you don't see it here, but you have to just go down. That's x equals 0, x equals 1 minus 1.7. Okay, you have minus 1.7 here. And when x equals 3, you go down further to x equals 3, y is equal to 2.1. So you can see there's some sort of a symmetry here. Okay, that's minus 2.1, that's 2.1, 1.6, minus 1.6, and so on, the opposite side, but the same numbers. Okay, so now we have filled out the table for our table of values, and now we need to draw the graph. Okay, we need to draw the graph of y equals 3x 3 over 10 x cubed minus 2x. So we got to plot these values in. So you have minus 3 and minus 2.1. Minus 3, minus 2.1. Now we got to see how much each of these squares are worth. You can see that each of these squares are 0.1. So minus 3 and minus 2.1 will be exactly at this point here. Now you notice what I've done. I've put a little dot and then I put a circle. If I put the dot, you might not even spot it in all of this, but if you circle it, you can see it very clearly. Or if you wanted, you could put a little cross like that. Okay, I personally prefer this dot circle, but this is fine. You can put dots, little crosses. But what you shouldn't do is big blobs. Many students make these big blobs, and that looks a bit silly and it looks inaccurate. Or many people put a tiny little dot without circling it, and then when you draw the line, you can't actually see the point. So if I make a dot like that and I draw a line through it, okay, if you draw a line through it, afterwards you can't see where it was. You can't see where the dot was, you see. But if you had a dot and a circle, you can see where the point was plotted. It's plotted right there. So these are little tips that you need to know when you're plotting these graphs. So you have x equals minus 3 and y equals minus 2.1. Now y equals minus 2 and x equals minus 2 and y equals 1.6. Now a big mistake that people make here is they stay in the negative side. They say minus 2 and minus 1.6. But it's not, it's minus 2 and positive 1.6, which is going to be right here. Okay, so be very careful when you are plotting your points that you don't make a mistake like that. Okay, be careful of the signs. It's minus 2 for x and 1.6, not minus 1.6 for y. And then minus 1.5 on x and minus 1.5 is here on x and 2.0, so it's right at this point here. And then you have minus 1 and 1.7. That's 1.5, 6, 7. It's right there. And then you have the origin 0, 0. Okay, and then you have 1 and minus 1.7. 1 and minus 1.5, 6, 7 right here. Okay, and then you have 1.5 and minus 2.1. 1.5 and minus 2.0, sorry. 1.5 and minus 2.0, so it's right here. And then you have 2 and minus 1.6. That's 1.5, 1.6. Okay, that was 1 and, yeah, okay. And then you have 2 and minus 1.6 and 3 and 2.1. 3 and 2.1, which is right there. Okay, so you can see that you're going to have a cubic curve. Right, now this is quite a difficult thing to do with this piece of software that I have. Okay, I'm going to try and do my best, but basically you have to, what I would do is I would keep my palm on the inside of the curve, okay, and then I'd do this part of the curve, and then when I'm doing the other part I would turn the page upside down, keep my palm on the inside and carry on. Okay, keeping your palm on the inside of the curve is something that's that will help you a lot. Okay, now what you can do is you can just join this together. It's not too bad so far. Oh, I spoke too soon. Okay, now you're supposed to make one clean stroke. Okay, not like what I'm doing, but this is not that easy on this piece of software that I have, especially on this part. Let me see if I turn it upside down here, will it work? It's like I'm looking at it. I don't know how good this will be. I'm working backwards now. No, that's not going to work. Alright, turn it back. Oh, okay. Now, so this part of it even still is, I just want to tidy it up a bit so that it looks a bit better. From here I'll tidy it up. It's a bit too thick there. What was it? Minus 1. What was it? Minus 1 and 1.7. Minus 1 and 1.7. And we had 0, 0 origin. Okay, so we're going to go down, 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 and then turn, and then up, and up through this point. Try and make it look like a curve. Okay, not too bad. This is not so easy when you're using this software that I've got here. It's a lot easier actually doing it on proper paper. I've tried my best. Okay. Alright, when you do this, of course, you must use a pencil. Okay, so that's sufficient for what I have. Okay, it's a bit jaggedy over there, but you're going to try and be a lot smoother. If you're using a French curve, I would advise you not to use it unless you're really an expert at it, because most people, if they use a French curve, they don't know how to use it properly, and the curve just comes out looking really completely wrong. The bits start curving upwards and in the wrong place and all sorts of things. So just try and keep it freehand. They don't expect perfection from you, but you know, just try your best. Okay, use a pencil and just try your best. So that's y equals 3x cubed, 3 over 10x cubed minus 2x drawn. Okay, now to continue to part C. Here we have to do the following. Part C, we have to, on the grid opposite, draw a suitable straight line to solve the equation 3x cubed minus 2x equals a half times 1 minus x. Now, in order to solve an equation graphically using a graph, what you should always try and do is to make sure that what is drawn, which is this, okay, which is this, y equals 3 over 10x cubed minus 2x. This is what's drawn. This is what we drew on the other page. Okay, what's drawn? Okay, and the equation I have to solve, which is this equation here, one side of this equation that you have to solve should look like what's drawn. Okay, and it does. If it doesn't, then you have to modify the equation, okay, to make one side look like what's drawn. But here we don't have to bother doing that because it already looks the same. 3 over 10x cubed minus 2x, 3 over 10x cubed minus 2x, so they're the same. Okay, if this was not the same as that, you would have to modify this to make it look like that, and whatever you did to this side, you'd have to do to the other side, and then you'd proceed. Okay, so once you make the equation, one side of the equation look like what's drawn, then you always draw the line y equals whatever's on the other side, which is a half times 1 minus x. So we need to draw this line. This is what we need to draw. Okay, we need to draw this line on the same pair of axes as the curve that we just drew, and then where this line and this curve intersect, we write down the x values. You can see there's going to be 3 of them. Okay, there's 3 spaces for the answers here. So let's go back to our curve and let's draw the line y equals half times, I think it was x minus 1, oops, wrong way, half times 1 minus x. Yes, half times 1 minus x. Okay, 1 minus x. So let's just expand this. That's going to give you a half minus a half x. Okay, you could draw that line, or if you wanted to draw it another way, you could do it. Let's multiply both sides by 2. You can say that's the same as saying 2y equals 1 minus x. Okay, now there's multiple ways of you drawing this straight line. One of the ways you could do it is to choose a value of x, okay, and then you know, it'll give you a value of y. For example, when x is 0, y is a half. Okay, so it's going to go through half, which is up here somewhere. This is exactly where half is. And choose another value of x, for example, when x is equal to, say, 1. When x is equal to 1, okay, you're going to have a half minus a half, which is 0. So it's going to go to that point over there. And then you can draw your line through those 2 points. A straight line, you only need 2 points. You don't need to make a table of values and lots of points. You just need 2 points on that line. Okay, so you could do it that way. Another way you could do it is by using this form. When x is 0, y is a half. When y is 0, x is 1. You get the same 2 values. So it doesn't matter how you draw it in terms of the method you use, but the point is you only need 2 points on the line. So you're going to draw a line that passes through these 2 points, and you make sure that it continues on both sides throughout the whole axis, so you catch all of the places where it's going to meet that curve. Okay. All right. So there we have the line drawn. Y equals half times 1 minus x. And our solutions, okay, to the equation that we were asked to solve, where the curve, okay, where 3x cubed minus 2x equals a half times 1 minus x, are the x coordinates of the places where they intersect. So what I'm going to do now is I'm going to see where they intersect and draw a line down until it hits the x-axis. There's 1 point over there. There's 1 point over here. Well, I've gone slightly too much to the right there. Let me just redo that one. There's 1 point over here somewhere. Okay, and there's another. Oops. My hand keeps slipping. Here we are. Yep, that's better. And there's another point over here where the curve and the line intersect. That's good. I've gone slightly to the right. Let me move it to the left a bit. Okay, see, this is important that you draw these lines so the examiner can see that you've done this using your graph, because the question does state very clearly, it says on the grid opposite, draw a suitable line to solve this equation. So you have to do it, you have to solve the equation by drawing the line and seeing where they intersect. Okay, you don't do it by using your calculator. But what I'm going to do now is I'm going to show you a method. Okay. Well, actually, no, it's not really worth doing that, to be honest. It will be a bit too much. Yeah, that's fine. So what I'm going to do here is I'm just going to write down the answers. So the answers are this point here, which is about 2.1234, so about 2.4. Okay, and there's this point over here which is 0.1234, 0.45, and you have this point over here which is like minus 2.05, about halfway between minus 2.005. So you got these three solutions here. That looks like it's slightly less than that, but that should be okay. See, this graph that we drew could have been a bit better, to be honest. Okay, but that's fine. So you got minus 2.05 and 0.45 minus 2. What was it? Minus 2.05 and 0.45, and minus 2.05 and minus 0.45 and 2 point something. It was 2.4. Okay, 2.4. All right, so those are three solutions to that equation. We solve that using the graph. Okay, there are other methods you could use to solve it, but that's not what it's not in our syllabus, and secondly, that's not what we're asked to do. Okay, so if you were able to solve it using some other method, okay, you wouldn't get the mark for this question, because it's telling you to do it in this way. You graphically, basically drawing the straight line, which is y equals 1/2 times 1 minus x, seeing where the line and the curve intersect. Now it says for x is between minus 3 and 3, the equation 3 over x cubed minus 2x equals 1 has a number of solutions called n. We've got to find out how many solutions they have. So again, this looks exactly like what's drawn. So to find the solutions to this equation, we have to draw y equals whatever's on the other side, which is y equals 1. So if we draw the line y equals 1, which is just basically a horizontal line that passes through 1 on the y-axis, if I drew the line y equals 1, it's going to basically be this line right here. That is the line y equals 1. Okay, and y equals 1 has a number of solutions, okay, with this equation, and you can see it hits the curve. Whoops, let me make that a bit thinner. We can see it hits the curve 3 times exactly. Okay, so you can see that's one solution here, that's another solution here, and that's another solution there. They're not asking us to find those solutions. Okay, they're not asking us to find those solutions, they're asking us to give us the number of solutions. It's 1, 2, 3 places where that line and that curve will intersect. Okay, so you can say n equals 3. And that's the answer to that question. And this is for x between -3 and 3. So yeah, everything is between -3 and 3. That's where we drew it from. You can see that there are 3 solutions to the curve, to that equation. And there we have question number, what was it? Question number 5 done. Okay. Okay, actually I just want to add something because I was going to show you something, then I decided not to, but now I decided that I should, because sometimes they do ask a question almost exactly like this. Okay, so basically the equation that we had to solve was given on the other page, which was this equation over here. So I'll just quickly copy it, if this works. Okay, and take it to the other side. So I've got some space to work. In fact, I can take it down here. Okay, so that's the equation they asked us to solve. Okay, now what I was going to show you is a way for you to check how accurate your answers are. Okay, just if you have time, like at the end of the exam, you want to be sure that you've done your graph accurately or whatever, you can check that your answers are correct. There's a way you can do it, and the way you can do it is to basically make this equation into just rearrange this equation so you have everything on one side and says equals 0. Okay, and sometimes they do actually tell you to do this. They say show that this equation can be solved by, you know, rearranging it into the form something x cubed plus something x plus something equals 0. You've got to give the values of that, like ax cubed plus bx. You've got to find what a, b, and c is. There's a few questions like that that you'll see in the graphs and functions folder that I have in the playlist. But I'm just going to show you how to do that for this, and then how to solve it using your calculator to check to see if your answers are accurate. So what I would do is, first thing here, I would just get rid of all the fractions. So I'd multiply both sides of the equation by 10. And that will get rid of the fractions here. So this multiplied by 10 will give me 3x cubed. And this multiplied by 10 will give you minus 20x. And this multiplied by 10 will give me 5 times 1 minus x. So if I expand that, now I have 3x cubed minus 20x equals 5 minus 5x. And if I now bring everything on one side, I'll have 3x cubed, have minus 20x plus 5x, which is minus 15x, and I've got to subtract 5 from both sides. So this is the equation that, if I solve this equation, I will find the values of x where this is true, okay, where the line and the curve intersect. So to solve this equation is outside the scope of our syllabus. However, I'll show you how to do it using your calculator just to check. Okay, what we can do is we go to now the mode for equations, okay, which I think is number 9. You can see the one x, y equals 0. That's the mode for equations. You can go there and you press equals. Now this is called a polynomial, okay, so we press 2. And then the degree is 3. Why? Because it's a cubic. Okay, the degree is 3, so we're going to select 3. So it's a cubic. Then they're asking us to write down ax cubed plus bx squared plus cx plus d. So you've got to write down the coefficient of x cubed. In this case, it's 3 here. And I press equals. Then the coefficient of x squared. Well, there's no x squared term here. So that means the coefficient of x squared is 0. So I put 0. I press equals. And the coefficient of x, which is negative 15, so I'm going to write negative 15. Don't forget the negative sign. Press equals, and then the constant, which is negative 5. Okay, and then I press equals, then I press equals again, and it will give me the solution. So they've got 2.38. Now, let's look at it up here next to my answers. 2.38. Now, one of my answers was 2.4, so that's pretty good. Okay, and then I press equals again to get the next solution, which is minus 0.34. That one's a bit out. Okay, it might be accepted. That one's slightly out. Okay, I'm going to check to see whether I've read it wrong. Okay, and the other solution is negative 2.05. Okay, that's almost exact. That's perfect. Those two are pretty much accurate. Let's look at now. Here we can go back and check to see. Maybe I made a misread. Okay, maybe I did this on purpose. Anyway, let's see. So I'm going to keep pressing equals again. Equals minus 0.34. That's the one. Okay, so minus 0.34. So I've got 1, 2, 3. Okay, now can you see here where I've drawn my curve? Okay, it kind of like caves in a bit here. Okay, so really I could now correct my curve. Okay, I could correct my curve at this point to try and make it a bit more accurate. So should be a bit more rounded and maybe come down a bit more like this. Okay, so you can actually go back and, you know, if you have time to just make sure that you're going to get the marks, you can it's kind of fiddling the answer, but it's you know, it's perfectly fine. All right, so you can just do this, make it a bit more rounded, and now you see that's a bit better. So you have now 1, 2, 3, 0.35. You see that made that difference there. So that's now 0.35. So that's a little tip that you can use, okay, to find out what the exact answers are. Okay, and if you have time, if you don't have time, don't bother doing that, because they're going to judge you by you know, your graph, where your graph hits the curve. Okay, so if you make a mistake in the curve and then you make a mistake in reading the value where, you know, where it hits the curve, you might lose marks. Okay, but that degree of accuracy, okay, they might accept. There's normally a limit between which they accept. So what I wrote down in my first answer might actually be within the accepted degree of accuracy, especially when you've got to draw the graph yourself. Okay, when you have to draw the graph yourself, sometimes there is some sort of leeway in terms of the degree of accuracy. But you see, what I did is I checked to see the answers, what they should be from the calculator, by doing this first, by, you know, rearranging this so you get everything on one side of the equation, and then I use my equation function on my calculator to solve this equation, and I compared my, you know, intersection points with that. So then I went back, and this one, it seemed a bit too much out for my liking, so I modified my graph, and I spotted that there was that part of my graph wasn't so accurate. It was a bit jaggedy here, so I kind of corrected it as much as I could, and you see it made a difference to the answer. But I wouldn't spend a long time if you don't have time. That's like, you know, you might have been perfectly fine. It might have been within the range. You know, just for 1 mark to go through all that is a bit of a palaver. But if you've got time at the end of your paper and you want to just, you know, try and go for perfection, then, you know, that's perfectly fine. Okay, so I hope that was useful.